Compound inequalities. Right. Okay, now we're either going to deal with situations where we have an and, let me get my pen going, an and or an or. Okay. Right, so let's do an and. Okay, so let's have a look at these two. Now these are using the same 2x plus 5. Okay, now you can solve this individually if you want to, but you can put it together like this, because it's an and, this one and this one. We can write it like that, because it's got the same 2x plus 5. If you had different equations, you do something a little bit differently. So, have a look at this. So there it is, we've put it together. Now, from this, how do we solve it? Well, to get to the x, can you see you're going to have to take away a 5. Now, you take away 5 from this side and this side. So take away 5 from a -3. I'll get -8. Take away 5 from a 7. I'll get 2. So I just took away 5 from everywhere. So I've still got the 2x. So you can see I'll end up dividing by 2. Divide by the number next to the letter. Again, divide the -8 by 2. You get -4. Divide the 2 by 2. You'll get 1. So I just divide everything by 2. And that's what I get. Okay. So the solution set is in between -4 and +1. Okay, including the +1. Again, because of the equal sign. So there is the sets notation. Okay, just written as he answered it. But that means, okay, and the thing about this means, this is going from -4, not inclusive, so use a parenthesis, to +1, okay, inclusive, so use a bracket, and that's why we have this as the graph, okay, sorry, pen's gone all over the place. Right, and that's the interval notation, okay, so that's doing an and. Again, you can read through that. Compound inequality, okay, a conjunction, right. Let's have a look at an or. Now again, this is using the same equation, 2x minus 5, 2x minus 5. Now again, if there were different equations, just solve them separately, okay? Now I can't put this together. As an or, it's like I've got two separate things. So unlike the and, where I can write it as one thing, okay, and solve individually, just like that, I've got to solve these individually. Okay, so again, minus 5, so add a 5. It's just the same equation, so I'm going to do both equations. Add a 5 to -7, I'll get -2. Okay, I just added a 5 to both sides. So that one, let's do it here. Add a 5. I'll get 6. So there we go. I'm now going to divide both sides by 2 because that's the number next to the letter. So x is less than or equal to -1, or x is greater than 3. Okay, again, I'm just looking at the actual inequalities. Okay, now if we were to graph that, think about it. Okay, from -1 bracket, because it's got the equal sign, we're going that way. There it is down here. And from 3, we're going that way with the parentheses. There it is. And again, let's look at the interval notation, set notation. So there we go. Two separate pieces now, okay? Again, it's not like this. We can write it as one answer, where it is there. See that there? Okay, that was the and. Look at the or. Two separate pieces. It can be x less than or equal to -1, or, go write it in, x is greater than 3. And that's how I have to write it. Now again, that's two areas. Now if you look at the graph, it's two separate areas. So it's interval notation. Now look at it. It's nice to see. Look at that. It's going from -infinity to -1 with a bracket. Okay. Visually, it's going from +3 to +infinity with a parenthesis. Okay. And we have that in there. Sometimes it's a union, okay, of these two. This one, you can think of it this one or this one, but that's the union, okay? And that's how you do it. Now, okay, so that's how you do those, how you write the answers, okay? But have a look at this, just quick visuals. Supposing, get away from the fact that you might not always have exactly the same equations. Suppose I came up with these. Okay, so supposing I get an answer 3 to infinity, okay? 3 to infinity, and another answer of 1 to infinity. Again, the two parts, the two equations. One's an and, one's an or. I've still got two equations, don't I? Now, as an and, can you see that if it's got to be in both, if it has to be in this one and this one, if the answer is this one and this one, then for the and, I have to choose this, okay? Because, think about it, 2, I can pick a 2, which is in this one, but it's not in the other one, is it? I mean, this one starts at 3 and goes to infinity. So as an and, if it's got to be in this one and this one, then this is the one I would have to pick if it was an and question, okay? It'd be 3 to infinity. Again, because 2, this second one will accept 2, but the other one won't. Now as an OR, if it's this one or this one, what's the better one to choose? This one, you've got more options. It's got a few more numbers because it's an OR. Well, this one or this one, let's choose that one as the answer. Okay, so again, if it was an AND question, I'd have to pick 3 to infinity. If it's an OR question, I'd pick 1 to infinity. You know, if these were my kind of solutions I found from the previous question. Now, supposing we look at this. Again, I'm just picking what could be an AND, what could be an OR. If this was an AND question, and this is the solutions I got, can you see, if it's got to be in both, basically, it's got to be this section here. Okay, this is the area that's got both. So the answer would be 1 to 5. And if it wasn't inclusive, I'd just use parentheses. Okay, can you see? If it's got to be in both, it can only be, see, look, 7. 7's not going to work. 7 works in this one, but where's the 7 here? Okay, so I can't have that. So as an AND, that would be the answer. Okay. Oops, I can't write AND. Now as an OR, if it's this one or this one, can you see it's going all the way that way, all the way that way? If it's either one of these, or that's negative infinity to positive infinity. Okay, so that would be the answer if this was an OR question. All right, so you know, I'm just thinking of what it might be. Here's the answers from the equations I solved. But if it's an AND, I have to pick 1 to 5. If it's an OR, I'd pick negative infinity to positive infinity. Okay, it kind of makes sense. Now, if these are solutions to, again, a question I had, I'm just making this up, okay? Then if this was an AND, there is no common area in this one and this one. It doesn't have a solution, okay? There's no solution to this one if it was an AND, okay? Because there's no common area. Think of it like that, like this one had, okay? Now then, if this was a OR question, then it'd have to be a bit like this. Okay, it's 2 separate areas, so you've got to write it like this. All right, so this would be negative infinity to 1. Okay, that's the top one there. And then it's a union 3 to infinity, and that's how I'd write it if it was an OR question. Okay, again, I'm just making these up. Actually, different situations. It's not always going to be just like, you know, this question or this question. Okay, so I'm just going to say, if you kind of solve them individually and figure out, okay, which is the AND, which is the OR, how do I answer it, then this is just visuals. This is just like looking at these graphs. Okay, it's always nice to look at the graphs and figure out what the solution set is. Okay, there we go.